Hello and a warm welcome to our presentation with the title Ethernet APL and OPCUA, Full Throttle from Instrument to Cloud. Before we start with our presentation, let us have a short introduction of ourselves. My name is Dr. Haehniche. I'm with Anderson Hauser Digital Solutions as Innovation Director, responsible for the innovation within Anderson Hauser Digital Solutions. In parallel to them, also Chairman of the Ethernet APL Steering Committee.
I am Andreas Hennecke. I'm Marketing Manager at Pepper & Fuchs for everything digital communications infrastructure in process industries, and I have a passion for Ethernet APL. I would like to introduce to you the features and benefits of Ethernet APL. So when we're talking about a process plant, we're looking at tens of thousands of signals in devices measuring pressure and temperature, or valves opening and closing. And the digital transformation to the process plant has not taken place in the field yet. For this, we would like to have direct access to diagnostics and configuration. We would like to be barrier-free from the edge to the cloud with the same protocol and communications technologies used throughout the plant, thus unlocking the potential of the field. This will be made available with Ethernet APL, because today, when you utilize OPCUA, you get down to the controller level, but not beyond, because this is as far as Ethernet technologies reach. The reason for this are the specific requirements from the field of process industries, such as the ruggedized technology that is required, high temperature ranges, long cable distances, and importantly also many plants deploy explosion protection technologies. Thus, technologies such as 4 to 20 milliamp signals have prevailed because of their robustness and their ease in application. Ethernet APL will change this. Based on similar technologies used today in the field, it provides a direct path for Ethernet from the management level and the cloud down to the field.
Now with Ethernet APL, we can establish one channel for control level integration, and the second channel could be used by OPCUA to provide additional information from the field device to the cloud. Important for that is that they have standardized information, and here PLDIM, a standardized information model for process automation, helps.
And you see that there's a lot more involved than just Ethernet communications. The PLDIM model, for example, takes place on a different layer of communications. But let's get back to Ethernet. When we all think of Ethernet today in our homes and our offices, we're thinking of Ethernet as something like this. The RJ45 connector that you plug into the wall outlet with your laptop, and you know it's always going to work. Now, this type of connector would look real jagged after a couple of months of vibrations out in the field. And those manufacturers providing this equipment today, because it does provide some benefit to the larger and more complicated field instrumentation, can attest to that. What our technicians are looking for in the field is a 2-wire cable. This is sturdy and ruggedized for this operation and for easy installation. This is something that our installations people and technical teams are very familiar with. And this is what Ethernet APL actually brings. It provides sturdy, ruggedized communication that includes power on a 2-wire cable. It has integrated explosion protection with intrinsic safety. It provides cable distances of up to 1,000 meters. And as a side benefit, actually, it provides 10 megabits per second speed of communication. Now, you may say 10 megabits, that's not much. I have a gigabit in my home. But consider that each of these instruments is only sending one value. And there's lots of them out there. The latest technology that we have in digital communication in the field communicates 300 times slower than 10 megabits. So this is a very, very large improvement over the technology available in the field today. Now we're all looking to standardize this.
Yeah, such a new technology cannot be developed and introduced without appropriate support. 12 industry partners and the 4 leading standardization development organizations support this development and activities. And we are happy that even OPC Foundation decided to join that project. It shows the importance of this new technology for every standardization organization, because there is a huge potential, as Andreas already mentioned. I'm also happy to see that this 12 industry partner covers each area of an automation solution, starting with the DCS system to system components to field devices like sensors and actuators. With this cooperation, the most important prerequisites are given that Ethernet APL becomes reality. Now let us have a deeper look in the outcomes of this Ethernet APL project. Ethernet APL is designed to incorporate intrinsic safety, but works for non-intrinsic safety applications as well. As Andreas showed, it is really a 2-wire solution, which allows the power supply and communication via this 2-wire. It is protocol independent. Since we used standard Ethernet interfaces, each protocol, industrial protocol, as you see here, or any other application can run over Ethernet APL. Also important is with this 2-wire that we have an easy and robust connection of the device, which is appropriate for the process automation industry. And even with Ethernet itself, it's a state-of-the-art technology which we are using. And that ensures a future-proven solution. Even the 10 megabit bandwidth gives us really a huge potential for additional use cases to be fulfilled or applications. In order to have this outcome done, several work packages and milestones have to be passed. One important part are the standards, because since the beginning, it was clear that we have to develop an open, standardized solution and not industry proprietary solution, which can only be used for specific part and is not open for everyone. So the standard gives us the possibility to be open to develop products out of them. New standards have been developed, like the IEEE 802.3CG standard, which was released in end of 2019, published in 2020, and the name is even 10 base T1L. That's the core of Ethernet APL. In addition to that, the explosion protection mechanism had to be defined. Here we used an approach which is already known in process industry called OPCUA, and the new solution has a name 2-wire intrinsic safe Ethernet, which is as a technical specification added in the IEC 60079-47. Other standards will come, like the port profile specification will also be standardized in IEC soon. It exists today now as a specification, will be published by the standardization organizations. In addition to that, the further specifications and guidelines have been developed in order to ensure the interoperability between the devices and makes the installation of Ethernet APL and the network design easy for the user. I'm really glad and proud that we are able to launch yesterday officially this new technology to the market. So that means everything is now available to start product development. We see also, or have seen in demonstrations, already existing products which can now be used in real projects. So, and I hope that this will be happen in the near future, that we have a lot of projects where Ethernet APL is used. To summarize the standards, and even as I said, the standards gives the possibility to have really for everybody access to that information for their own development. It's even the new standard IEEE 802.3 CG, which describes this 10-base T1L solution. Then the IC technical specification for this two-wise concept. We reuse existing cable specifications like this IC 61158.2 type A cable. And soon we will have an extension of this IC 61148.2 standard by the port profiles. This standard ensures that we have protocol independency, that it's robust, and we can reuse existing cable, and we ensure the interoperability between the devices, as well as easiness of installation and commissioning of an Ethernet APL network. The process industry is facing a radical change in terms of digitalization. So more information from the field are required to increase the efficiency of production, but also maintenance processes, together with an increase of quality. On the other hand, it is expected to decrease the total costs of ownership by this digitalization. So OPCUA as a second channel gives the opportunity to have easy access to all this information in the device on a standard way. So that reduces the risks, makes it simpler to get access to that data, and that's what is required if you would like to do digitalization. Why we can do that? It's because now we have enough bandwidth available to run in parallel different protocols. So in that way, we can even support the real-time control for process. We can provide asset management applications on the same network, as well as process monitoring and optimization. So that means we have one network technology where all these applications protocols can run in parallel. The benefit for us is to give more flexibility and scalability. We can ensure the availability by redundancy concepts, and sure, security is also a topic, and with such a solution, a secure communication can be ensured.
So to summarize all this, one of the important aspects is that Ethernet, as opposed to our existing communications that are pretty much proprietary to the field of process plants, provides this type of parallel communication. It provides it on two wires. Now, having all of this will allow users to optimize their assets by accessing additional process variables or gaining higher accuracy through a digital transmission. This will also help improve quality and reduce waste. Ethernet also has the benefit of being extremely scalable. This means that skids that are already fitted with Ethernet can easily be integrated into larger plant concepts. This also means upscaling of smaller plants and reactors to full-scale production. And one of the important aspects of Ethernet as the carrying medium of data to the field of the process plants is that it is future-proof. Ethernet will always adapt and adopt to the latest standards as they develop today, for example, for safety and/or security. We will also see system integration improve. Consider that each and every instrument will automatically connect to the engineering station because Ethernet allows two-way communication and network communication. And with diagnostics and troubleshooting, the technicians have access to the data that is stored in the engineering station and at the same time to the manual that is stored in the instrument or the certification documentation. So with advanced techniques, Ethernet APL enables these techniques to be deployed in the field and providing information at the right time and where it is needed. Finally, installation technologies are a lot easier to harness with a physical layer that a lot of technicians are familiar with today, and that is our simple two-wire cable. So all in all, we're getting a barrier-free communication that reaches for OPCUA from the cloud all the way down to the edge, full throttle. So what would be your next steps to deploy Ethernet APL? There are a couple of options. If you are a vendor, connect with the experts of Ethernet APL to learn how to get involved. If you're a plant operator, connect with the subject matter experts to figure out how to develop a plant, or possibly as a first step, take a virtual tour of our Ethernet APL multi-vendor demonstrator. Finally, we would like to invite you to our October event. On October 5 and 6, we will be conducting educational series and have longer discussions than what we have available today. Thank you for listening.
Thank you.
We also invite you to look at the streams and the recordings of Exhibitor Channel 3, where you have had the opportunity to review the technical details and presentations from the subject matter experts that developed Ethernet APL.